Hello. So how are you going to go and solve a perfect square trinomial? Well, so a perfect square trinomial, what we'll talk about here is ax squared plus bx plus c, where, remember, our a and our c are going to be squared terms, and then our b is 2 times the square root of a times the square root of c. Gets a little confusing, but we'll go over a problem like this. So anyways, one of the first steps that we need to do is make sure we have our quadratic set equal to 0, right? Because we're going to be factoring. And so we want to set the values of x. When we're solving, we want to make sure we set this equal to 0 so we can factor and either use the square root method or the zero product property. And I'll explain a little bit more on that in a second. So we're going to want to be solving, so we have to set this equal to 0. All right. Now, what I'm going to do is I'm going to give an example of just in common terms. There might be a problem in this chapter. I don't even know. I'm just going to make it up. So we have 9, which you can turn as a squared number, right? Because 3 times 3 equals 9. And then I'll have 16, because 4 times 4 is 16. And then 4 times 3 would be 12. OK, so this would be a perfect square trinomial because it passed the test. Remember, the tests are 16 is a squared number, and 9 is a squared number. And 12 passes the test of 2 times the square root of 9 times the square root of 16. Right? Remember, it's the square root of a times the square root of c times 2. Well, let's double check. The square root of 9 is 3. Square root of, that should be 24. You're right. I forgot to double by 24, right? Square root of 4 is 4. 2 times 3 is 6. 6 times 4 is 24. So therefore, that should be a middle term 24. So I'm making up this problem as I go. But I swear, all the problems in the course are actually perfect squares. I'm trying to make this one up, but I want to go through what exactly we're going to do. So when you go to look to factoring this, all right, we know that factoring this, we're going to have set up as 2 binomials. Now remember, these first 2 terms multiply to give us 9x squared. So what we pretty much do to find if this is our a, we're going to be taking the square roots of this term. So we'd have 3x and 3x. Because 3x times 3x, you remember when you apply FOIL, 3x times 3x equals 9x squared. Then I go into the 16. Well, what 2 terms are going to give us 16? Either positive 4 and positive 4 or negative 4 and negative 4. And the difference is going to be looking at the sign of our middle term. If the sign of our middle term is negative, then our 2 other factors have to be negative. If the middle term is positive, like we have here, then my 2 other factors are also going to be positive. All right, so that's very, very important. Because we notice that 4 times 4 is 16, but it also could have been negative 4 times negative 4. But that would provide us with a negative middle term. So just very careful with that. And then we can always double check your work on top by doing 4 times 3x is 12x plus 3x times 4x, which is 12x, which again would be 24x, which is our middle term. So what do we do now? Well, there's a couple different ways we could solve.
LaRon Brown, please report to the main office. LaRon Brown, please report to the main office.
Sorry about that. So there's a couple of different options that we can go from here, all right? One way is we can rewrite this as a binomial square. 0 equals 3x plus 4 squared, right? If you have 3 times 3, we can rewrite that as 3 squared. So the reason why I do this is really just dependent on how you want to solve for this. Here, I can solve this by using the zero product property. Set these both equal to 0. Now, you might say this is a little bit of wasted work because it's the exact same binomial that you're setting equal to 0. And when I solve, I'm going to get the exact same answers. I'm not going to do it twice. Equals negative 4 over 3. Right? You can see I get the exact same answers. But now let's go over here and see how it would work with the square root method. Well, the square root method is just using your inverse operations. So therefore, what you guys can see in this example is that you're just going to have one solution at x equals negative 4 divided by 3. And it doesn't matter if there's 2 of them in this case. It doesn't matter if there's 2 in this case, for at least as far as solving goes, this is going to be our only solution. So there we go, ladies and gentlemen. That is pretty much the idea what you're going to be dealing with. These a and c's, they're going to be perfect squares, but sometimes they're not always going to be in the easiest of format. So it's just going to be very important to make sure we can identify them and then rewrite them in as their factored form. And then there's two different ways we can really go about solving them. Thanks. Hello.